Hey there, science fans, have you ever seen a magnet pick up paper clips? It's like magic, right? But did you know you can use electricity to make your own magnet? It's true. We can turn a simple nail into a magnet with just a few things. Are you ready? Let's go. Before we start, let's understand a bit about magnets. Magnets have two poles, north and south. Opposite poles attract each other, while the same poles repel. This is the basic principle behind how magnets work. Now let's dive into making our own electromagnet. To get started, we need a few things. First, find a nail. Any iron nail will do. Then, grab some copper wire. Copper is a good conductor of electricity, which is why we use it. You'll need a battery too. A simple AA battery works great. Finally, gather some paper clips. These will help us see the magnetic magic in action. Make sure you have everything ready before we move on to the next step. It's important to have all your materials prepared to ensure a smooth experiment. Now comes the fun part. Wrap the wire around the nail. Leave some wire free on both ends. Don't wrap it too tightly. We need electricity to flow through. First, take a long piece of copper wire and start wrapping it around the nail. Make sure you wrap it neatly and evenly. Leave some wire free on both ends. These free ends will be crucial for connecting to the battery. Don't wrap it too tightly. We need electricity to flow through. A loose coil ensures that the current can pass through the wire efficiently. Now take one end of the wire and connect it to the positive side of the battery. This is where the electric current will start flowing. Connect the other end of the wire to the negative side. Be careful. Make sure the connections are secure. What's happening? Hold the nail near the paper clips. Did they jump to the nail? Congratulations, you made an electromagnet. The electricity flowing through the wire creates a magnetic field around the nail, turning it into a magnet. This is a simple demonstration of how electromagnets work. You can experiment with different numbers of wire turns and battery types to see how they affect the strength of the magnet. Well done. Electromagnets have a fascinating history. The first electromagnet was invented by William Sturgeon in 1824. He demonstrated that by wrapping a coil of wire around an iron core and passing an electric current through the wire, the iron core became magnetized. This discovery paved the way for many technological advancements. Electromagnets are now used in various applications, from electric motors to MRI machines. Understanding the history of electromagnets helps us appreciate their importance in modern technology. Electromagnets are super useful. They help us lift heavy things in junkyards, power high-speed trains, and even make our doorbells ring. For example, in the medical field, MRI machines use powerful electromagnets to create detailed images of the inside of the human body. In the automotive industry, electromagnets are used in electric motors to power vehicles. The possibilities are endless. Electromagnets are incredibly versatile and have numerous practical applications. In junkyards, large electromagnets are used to lift and move heavy metal objects. Imagine the power it takes to lift an entire car with just the flip of a switch. In transportation, electromagnets are the secret behind maglev trains, which float above the tracks and move at high speeds with minimal friction. These trains are not only faster, but also quieter and more efficient than traditional trains. In medicine, MRI machines use powerful electromagnets to create detailed images of the inside of the human body. This allows doctors to diagnose and treat conditions with incredible accuracy. These are just a few examples of how electromagnets are used in our daily lives. Their ability to be turned on and off makes them especially useful in many different fields. Whether it's lifting heavy loads, speeding up transportation, or saving lives in hospitals, electromagnets play a crucial role in modern technology. So next time you see a maglev train, or hear about an MRI scan, you'll know that it's the power of electromagnets at work, making our world more efficient, advanced, and connected. While working with electromagnets can be fun and educational, it's important to follow safety precautions. Always use insulated wire to prevent electric shocks. Make sure the battery and wire connections are secure to avoid short circuits. Never use a battery that is too powerful, as it can overheat the wire and cause burns. Always disconnect the battery when you're done experimenting. By following these safety tips, you can enjoy learning about electromagnets without any risks. Electricity can create a magnetic field. This fascinating phenomenon is at the heart of many modern technologies we use every day. When electricity flows through the wire, it makes the nail magnetic. This is because the electric current generates a magnetic field around the wire, which then magnetizes the nail. It's like the electricity is giving the nail superpowers. Suddenly, the nail can attract small metal objects just like a regular magnet. But here's the catch. It's only magnetic when the electricity is flowing. Once you disconnect the wire, the nail loses its magnetism and goes back to being just an ordinary nail. Disconnect the wire, and the magic fades. Electromagnets are super useful. They can be turned on and off, making them incredibly versatile for various applications. They help us lift heavy things in junkyards, power high-speed trains, and even make our doorbells ring. These tiny forces working together have a huge impact on our daily lives, and even make our doorbells ring. Remember, science is everywhere. From the smallest gadgets to the largest machines, electromagnetism plays a crucial role. Keep exploring and asking questions. The more you learn about these tiny forces, the more you'll understand the world around you. You never know what amazing discoveries you'll make. So, stay curious and keep experimenting. The world of science is full of wonders waiting to be uncovered.